Inside this sugarcane biorefinery, one crop becomes white sugar, ethanol, green power, and fertilizer material. The process reveals how sugarcane can become food, fuel, power, and agricultural material. The process begins in the field, with mature sugarcane ready for harvest.
Field inspection checks whether the cane is ready for high-yield processing.
A model harvester cuts the cane and turns stalks into billets.
Fresh cane billets are loaded into trucks for immediate transport.
Large leaves and field trash are reduced before the cane reaches the mill. The harvested cane moves quickly to the factory to preserve juice quality. At the biorefinery, every cane truck enters the receiving system.
The weighbridge records the incoming cane load for yield tracking.
A sampling probe collects cane samples before unloading.
Samples help the factory estimate sugar content and processing yield.
The truck tipper unloads cane onto the receiving conveyor.
The receiving conveyor feeds cane steadily into the preparation line.
The washing system removes soil, dust, and field debris from the cane.
White trash and leaves are separated before the cane is chopped and shredded.
Metal detection helps protect the chopping and milling equipment.
Clean cane enters the chopper to prepare it for shredding.
Chopping increases the surface area before the cane reaches the shredder. The chopped cane enters a shredder to open the fibers. Shredding opens the cane fibers so the milling train can extract more juice. The milling train squeezes juice from the shredded cane.
The first mill releases a strong flow of raw cane juice.
Multiple roller stages extract more juice from the cane fiber.
After extraction, the remaining fiber is called bagasse.
Raw cane juice is collected and sent to screening.
Screening removes small cane fibers from the raw juice.
Screened juice moves into a tank before clarification.
Clarification prepares the juice for cleaner sugar production.
Clarification separates cleaner juice from mud and suspended impurities. The mud fraction is filtered to recover liquid and produce filter cake. Filter cake becomes an agricultural byproduct stream.
Clarified juice is pumped to the evaporator station.
Evaporation removes water and concentrates the cane juice into syrup. As water evaporates, the juice becomes thicker and sweeter.
The concentrated syrup is stored briefly before crystallization.
The syrup enters a vacuum pan where sugar crystals begin to form. Controlled crystallization forms sugar crystals inside thick syrup. The crystal-rich massacrete moves to centrifuges for separation. Centrifuges separate sugar crystals from remaining syrup.
Spinning separates crystals from the darker molasses.
Raw sugar crystals leave the centrifuge and move toward refining.
Molasses becomes a separate stream for ethanol production. Raw sugar is melted again for refining into white sugar.
Filtration and decolorization help produce a clearer refinery syrup. Refined syrup crystallizes again to form white sugar crystals. A second centrifuge stage separates the refined white crystals. Fresh white sugar crystals still contain moisture and need drying.
A fluidized bed dryer removes moisture from the white sugar crystals.
After drying, the sugar is cooled before screening and storage.
Screening creates a uniform crystal size for finished white sugar.
Finished white sugar moves into a clean storage silo.
Finished sugar samples are checked before packing.
The approved sugar moves from the silo into the bagging line.
Measured portions of white sugar are filled into bags. The filled bags are sealed for storage and transport.
Check weighing confirms each sugar bag is filled correctly.
Approved sugar bags are stacked onto pallets for warehouse storage. Molasses from sugar separation becomes the feedstock for ethanol production. Molasses is diluted to prepare it for fermentation.
The prepared molasses feed enters fermentation tanks.
Fermentation converts sugar-rich molasses into an ethanol-containing liquid. Samples confirm when fermentation is ready for distillation. The fermented liquid enters a distillation column to separate ethanol. Distillation separates ethanol from the fermented liquid.
The ethanol stream is stored in closed tanks for controlled distribution.
Ethanol samples are checked before shipment.
Bagasse moves from the milling train to the biomass boiler system. Bagasse is stored and fed steadily into the boiler. The boiler uses bagasse to generate steam for the factory. Steam from the boiler moves through insulated pipes toward the turbine. The turbine converts steam energy into electricity for the biorefinery.
Cooling systems support steam and power generation.
Generated power helps run parts of the Sugarcane biorefinery.
Filter cake from clarification moves into a fertilizer material line.
The audio features a female voice speaking a continuous rumble.
Conditioning improves the texture of the fertilizer material.
The fertilizer material is packed separately from the food production area.
The biorefinery creates sugar, ethanol, energy, and agricultural material from one crop.
The first stage moves cane from field harvest to factory receiving. Washing, chopping, and shredding prepare the cane for efficient juice extraction.
The milling train separates the cane into juice and fibrous bagasse. Screening and clarification clean the juice before sugar crystallization.
Evaporation, crystallization, and centrifugation create the first sugar crystals. Refining turns raw sugar into clean white sugar crystals.
White sugar is dried, screened, packed, and prepared for distribution. Molasses becomes ethanol through dilution, fermentation, and distillation.
Bagasse fuels a boiler that generates steam and electricity.
Filter cake becomes an agricultural material instead of being wasted.
Sugarcane stores sweet juice inside a fibrous stalk.
Raw cane juice is sweet, but still contains fibers and impurities.
Evaporation turns clarified juice into thick syrup.
Finished sugar quality depends on crystal size, color, and dryness.
Molasses is the dark syrup stream used for ethanol production. Distillation produces a clear ethanol stream stored in closed systems.
Bagasse is the fibrous material left after juice extraction.
Filter cake is separated from the juice clarification process. Sugarcane biorefining creates several outputs from one agricultural crop. Food-grade sugar production requires clean handling and protective clothing. The biorefinery combines food production, fuel production, and power generation under strict safety controls. Food contact surfaces are cleaned to protect finished sugar quality.
Heavy milling equipment is inspected regularly for safe operation.
Steam and syrup systems are checked to prevent leaks and heat loss.
Ethanol systems use sealed lines and strict safety checks.
The boiler section is monitored carefully because it powers the factory.
Quality control follows every major stream in the biorefinery.
Finished white sugar is stored in a clean, dry warehouse.
Ethanol is stored in closed tanks before distribution. Bagasse power helps make the sugarcane process more integrated.
Fertilizer material is stored separately from the food-grade sugar area. Packed white sugar leaves the warehouse for distribution.
Ethanol is loaded through closed transfer systems.
The power section connects bagasse fuel to steam and electricity for the plant.
The biorefinery uses cane juice, molasses, bagasse, and filter cake instead of wasting them. The main sugar stream begins when rollers extract juice from the cane fiber. Crystallization creates sugar crystals, and centrifugation separates them from syrup.
Molasses becomes ethanol through controlled fermentation and distillation.
Bagasse becomes biomass fuel for steam and power generation. Filter cake becomes an agricultural material stream from the juice clarification process. The finished outputs show how one crop becomes food, fuel, energy, and agricultural material. A modern biorefinery connects sugar production with fuel, energy, and agricultural byproduct recovery. First, the factory turns fresh cane into raw juice and fibrous bagasse. Then, cane juice becomes refined white sugar through clarification, evaporation, crystallization, and packing.
The molasses stream becomes ethanol through fermentation and distillation. The bagasse stream becomes biomass fuel for steam and green power. Finally, finished products are tested, packed, stored, and shipped.
What begins as a simple cane stalk can support food, fuel, energy, and farming. The value of a biorefinery comes from using every major sugarcane stream. From sugarcane to white sugar, ethanol, green power, and fertilizer material, every stage depends on extraction, separation.
Thank you for watching Mega Processing Tech. Subscribe, like, share, and comment what industrial process we should explore next.